Hi, I'm Papia. In this problem, we have the function c of x equals 2x cubed plus 3x squared minus 1. We have to find all possible rational zeros of this function. So, notice that 2 is the leading coefficient of this function. And the constant term is negative 1. Using those two numbers, we can say that the possible rational zeros of the function can be determined by taking the factors of the constant term divided by the factors of the leading coefficient, which is 2. So, let's think about it. What are the factors of negative 1? Well, they are either positive 1 or negative 1. So, we have plus or minus 1 in the numerator. And what are the factors of 2? Well, they are either plus or minus 1 or plus or minus 2. Those are all the factors. Okay, so let's figure out what are the possible numbers that we can get, which are rational numbers, which will possibly be a 0. So let's write down all the numbers that we get. So numerator is either plus or minus 1. Denominator, we have 4 choices. So if you take positive 1 from the numerator and write down all the factors in the denominator, you get 1 over 1, 1 over negative 1, 1 over positive 2, and 1 over negative 2. Well, we have to do the same thing with negative 1 in the numerator. So if you do that, you get negative 1 over positive 1, negative 1 over negative 1, negative 1 over positive 2, negative 1 over negative 2. So there are 8 choices. But if you notice carefully, some of them are repeated, right? So let's write down the distinct possible zeros that we have. So we have 1, negative 1, 1 half, negative 1 half. Then the last 4, look, this one is negative 1, which we already have written. This is positive 1, negative 1 half, and positive 1 half. So we don't have to write them again. So these are the possible rational zeros of the function. How can we check? Well, we can quickly try a synthetic division to check which ones are zeros and which ones are not. All right, so let's take the function, write down all the coefficients. Be careful, notice that there is no x term, therefore the coefficient of x term is 0, which we have to consider. All right, so the coefficients are 2, 3, 0, and negative 1. Okay, let's check if the first number, if 1, is a 0 or not. So write down 1 here, and let's do the synthetic division. Bring down 2. So 2 times 1, you have 2. 2 plus 3 is 5. 5 times 1 is 5. Add 5 and 0, you get 5. 5 times 1 is 5. 5 minus 1 is 4. You see, you don't get a remainder of 0. And therefore, 1 is not a possible, it's not a 0 of this function. Okay, so let's try one more time. Let's try negative 1. So 2, 3, 0, and negative 1. And use negative 1. Okay, bring down 2 again. 2 times negative 1, you have negative 2. Plus 3, you get 1. 1 minus 1, multiply, so it's a negative 1. Negative 1 plus 0 is negative 1, and then negative 1 times negative 1 is positive 1. When you add with the negative 1, you do get 0. So this is telling you that negative 1 is a 0 of this function. Okay. All right. So 1, 0 is x equals negative 1. Okay, let's check the other two numbers that we have. Okay, so we have the coefficients are 2, 3, 0 and negative 1. Let's try 1/2. Okay, bring down the 2. 2 times 1/2 is 1. 3 plus 1 is 4. 4 times 1/2, that's 2. 2 plus 0, we get 2. 1/2 times 2 is 1. And 1 minus 1 is 0. Well, remainder is 0. Therefore, we get another 0 to be 1/2. All right. Now, notice at this point that this function, this polynomial, its degree is 3. So, we know that it has 3 zeros, and we already found 2 of them, okay, both rationals. So, a third 0 will be a rational one as well. And we have one more choice here, negative 1/2. So, let's try that. Let's use the coefficients again. And use negative 1/2. Okay, bring down 2. 2 times negative 1/2, that's negative 1. Negative 1 plus 3, that's 2. Again, 2 times negative 1/2 is negative 1. You add, you get negative 1. Negative 1 times negative 1/2 is positive 1/2. Obviously, you see right away that this remainder is not going to be 0. 1/2 minus 1 is negative 1/2, and that is not 0, which means negative 1/2 is not a 0. So, we have 2 zeros, one is negative 1, one is 1/2. So, what will be the third 0? Well, maybe one of them is repeated, right? So, let's quickly check which one is repeated. Let's check with x equals negative 1. How can we check that if it is a repeated 0 or not? Well, remember for negative 1, this is the synthetic division here, right? So, if you consider these coefficients and try to use synthetic division again with negative 1, we can easily check if that's a repeated one or not, right? Okay, so let's try that here. So, we have 2, 1, negative 1, and we try negative 1 again. So, bring down 2. 2 times negative 1 is negative 2. Negative 2 plus 1 is negative 1. Negative 1 times negative 1 is positive 1, and you add, you get 0. So, this is telling you that negative 1 appears twice. So, in the factor, x plus 1 appears twice for this function. All right. So, we have all the rational zeros. They are negative 1 repeated twice and 1/2. So, those are the 3 rational zeros of the function c. Thank you.